Hi guys, today we're going to talk about solving equations with justification. These are the properties of real numbers that we know since elementary school and we use all the time when we solve equations. We have the commutative property, and here we have a typo that we need to take care of. Commutative. It's coming from the word commute, which means letters and numbers are going to switch order. We have the associative property, and then where the parentheses switch their position, but the numbers or letters do not change their order. And then we have the distributive property that we have been using for a long time. Along with these properties, we have the properties of equality that will help us solve equations. And these are new properties that you guys need to know. The first one is the additive property of equality. And we use this property when we add or subtract the same quantity from both sides of the equation. And the second property is the multiplicative property of equality. And we use this property when we multiply or divide the same quantity from both sides of the equation. Let's take a look at the example that we have here. We have 5x plus 2 times 1 plus 3x equals 13. We're going to use the distributive property as the first step to get rid of the parentheses. So I'm going to end up with 5x equals 2 times 1, which is 2, 2 times 3x, which is 6x, equals 13. Now I'm going to use the commutative property to switch the order of 2 and 6x, which allows me to have like terms next to each other, which I can combine together. 5x plus 6x equals 11x. Now this is a two-step equation. To be able to solve this two-step equation, I'm going to use the additive property of equality to take away 2 from both sides of the equation, which allows me to end up with 11x equals 11, which is a one-step equation. I can use the multiplicative property of equality to divide both sides of 11 and to isolate x by itself, and x will be equal to 1 in this case. So I solved the whole equation, and I provided the justification for each step it took place to be able to isolate the x in this example.